I want to find the radius of convergence for this series, and what I'm going to do is use the ratio test. So I'm going to take the n, or the negative 1 to the n and make it n plus 1. So wherever there's an n, I'm going to put n plus 1. So n factorial is going to change into n plus 1 factorial. And then x to the n is going to change into x to the n plus 1 all over. N to the n, that's going to be converted into n plus 1 to the n plus 1. Now I'm going to multiply that by the reciprocal of this original. So I'm going to flip that and just place it over here. So the bottom is going to become the top, that's n to the n. And the top's going to become the bottom, that's negative 1 to the n times n factorial times x to the n. And I close the absolute value bar. Now what I need to do is simplify as much as I can. Let's try to rewrite some of this so it's easier to see. Negative 1 to the n plus 1 is the same as negative 1 to the n times negative 1 to the first. And notice that this negative 1 to the n and this negative 1 to the n are going to simplify. So I'm going to start my new simplified version over here. And I'm just going to have a negative 1 to the first, which is negative 1. Now I'm going to take a look at n plus 1 factorial and n factorial. Notice n plus 1 factorial can be rewritten as n plus 1 times n factorial. And that's divided by n factorial. So notice also that this n plus 1 and the factorial part of it is going to cancel out with that factorial part. So all I'm going to be left with on the top is n plus 1. So that's going to be times n plus 1. Now I have the x to the n plus 1. Well, x to the n plus 1 could be x to the n times x to the first. And let's take a look. X to the n and x to the n are going to simplify. And that's just going to leave me with x to the first on the top. Now this one's a little bit more drastic. That's n to the n, and that's not going to simplify. That's going to be n to the n over n plus 1 to the n plus 1. Well, to the n plus 1, see the n plus 1, can I just multiply that by n plus 1 to the 1? Doesn't that equal n plus 1 to the n times n plus 1 to the 1, and then I add those and I get n plus 1 to the n plus 1. So more is going to simplify. More is going to simplify. Notice the n plus 1 and the n plus 1 simplifies. And this is going to give me negative x times n to the n over n plus 1 to the n absolute value. Now when I do the ratio test, the ratio test definition says that I'm supposed to take the limit of this as n approaches infinity. And that's supposed to be less than 1. It's supposed to be less than 1. But before I put the less than 1, I'm going to take the limit of this. But I can pull out the negative x. Because it's absolute value, it's going to be just an x that comes out. And I'm going to write absolute value of x times the limit as n approaches infinity of n over n plus 1 to the n power. And I want to see what that does as n approaches infinity. Now, here's the issue. I don't recognize what that is, but I do recognize that 1 plus 1 over n to the nth equals e as n approaches infinity. And I can rewrite that as n over n plus 1 over n. And then I can rewrite that as n plus 1 over n. Now I know that equals e. The bigger n gets, it approaches e. And this is the reciprocal of this. So, I can rewrite this as the limit as n approaches infinity of absolute value of x times the limit as n approaches infinity of n over n plus 1 to the n, and this equals 1 over e, equals absolute value of x times 1 over e. And now I'm going to set that less than 1. Now I'm going to solve this for x. I multiply both sides by e. That gives me the absolute value of x is less than e, and that is my radius of convergence, which is choice C. Not the easiest problem to put your brain around. I'm going to take the derivative of this because it wants the derivative of h prime at x equals 1.35. So h prime of x is going to be f prime of g of x times the derivative of the guts, which is g prime of x. Now I'm going to evaluate this at h prime of 1.35. So let's see here, what's g of 1.35? What's g of 1.35? G of 1.35 is 2.7. So I'm going to place 2.7 over here in for that. That's going to give me f prime of 2.7. I wonder what f prime of 2.7 is. That's going to give me 3.97. So this is 3.97. It took me 2 steps to get there. Now this is the tricky part. I don't have a g prime graph. I don't have a g prime graph. And it wants to know what g prime of x is. So in order to find g prime of 1.35, g prime of 1.35, at g of 1.35, I'm going to use a rock, okay, to find the slope at 1.35. Notice 1.35 is directly between 1.30 and 1.40. So I'm going to do g of b minus g of a all over b minus a. G of b is 2.9 minus G of A is 2.5 over B minus A, 1.4 minus 1.3, and that's going to give me 2.9 minus 2.5 is 0.4 over 1.4 minus 1.3 is 0.1. 0.4 divided by 0.1 is 4. And now I'm supposed to take that 4 and multiply it by 3.97. 15.88. And there it is, choice A. Number 3, notice it wants to know what f of 7 is. It gives me f of 2, and f of prime is this big clunky equation. So I'm just going to set up, I know that the integral from 2 to 7 of f prime of x equals f of 7, which I don't know what it is, minus f of 2, which I know is 8. So basically to find out what f of 7 is, I just add 8 to both sides. And when I enter this into the calculator using that formula, it'll give me what f of 7 is. So this one is obviously calculator active from 0 to 5, so I don't know where 5 is on this. Let me see, let me do an evaluate. Second calc value at 5. So 5 is way over here, and I'm looking for where this is not differentiable. Now, where it's not differentiable is where these little cusps are. And I have choices, so I'm going to enter those choices in. I'm already in value mode. Let me show you. I'm going to hit second calc, and it's going to go to value, and I'm just going to type in 0.9 and see if that lands me on a cusp. And it does. So 0.9 is not differentiable. Then I'm going to type in 2.4. I don't even have to retype it. It's pretty nice. And that lands me on a cusp. And then I type in 3.7. That almost lands me on a cusp. So, being that this is AP, BC, it says approximately at which coordinates. I'm going to put an 80 on that one. And now I'm going to type in these other ones. 0.4, definitely not at a cusp, so it can't be B. 2.4, at a cusp. 4.5, not at a cusp. It can't be that one. 0.9, we already said yes. 1.7, no. So it can't be that choice. It has to be not differentiable at these coordinates. All right, number 5. So I have f of x, the sine x is defined on the interval from 0 to b. The line tangent at x is parallel to the segment connecting 0, b. So let's see, math 8, ddx of sine x at x equals 1.531. So 0.03978 is the slope. So if I have a quick cheesy graph of sine, and this is 2 pi, this is pi, this is pi over 2, 3.14, 1.57, so the slope here is, I don't know, 0.3 something. 0.03978. And it keeps going, right? So that's the slope at some point, approximately on that little spot, and now there's some point B. Oh no, there's some point B. Alright? And x value is B, and now it's going to be parallel. From 0 to B. From 0 to B, there's some point. So, I'm going to do A rock. Average rate of change. So that's going to give me some point B minus some point A, which in this case is 0, over B minus A, which in this case is 0. And that's going to equal that slope because it's parallel to it. 0.03978, we'll say. Well, sine 0 is 0. So this is going to give me sine B over B equals 0.0398, and I'm stuck. But it's calculator active. It's calculator active. So I'm going to abuse the calculator. I'm going to go to y equals, I'm going to clear that out, and I'm going to graph sine B over B. Sine B over B. So here I go. Sine x over x, because I'm trying to find some value of b, so I might as well call it x. And I want to graph that. Now notice this isn't the graph of sine, this is the graph of sine x over x. And here's the deal, I'm going to go to value, and where I plug in this value, if it equals 3.0398, that would be my answer. So I'm going to plug in 2.704. Nope, it doesn't equal it. So it can't be A. I'm going to plug in B, 4.787. Nope, doesn't equal 0.0398. I'm going to type in 3.567. 3.567. Nope, it doesn't equal 0.0398. So now I'm going to type in the last one. I hope it works, otherwise I'm doing this for nothing. 3.021. And there it is, 0.0398. Choice D. Water's being pumped in continuously. That means it's nice, proportional to the amount of the water left in the pool. This is a diffy Q. Initially there were 500,000 gallons in the water, and 10 days later, that's probably an initial condition. That's 0, 500,000, then 10, 100,000. So I'm going to separate the variables. So I have dy, 1 over y dy. I'm going to divide both sides by y, which gives me 1 over y dy. And I'm going to kick the dt over to the other side, k dt. and then I take the integral of both sides. That's going to give me ln of y equals kt plus c. I'm going to solve this for y, so I base e it, and that's going to give me y equals e to the kt plus c, but that would be the same as e to the c, because I add the exponents, and e to the c can be rewritten as c up front. So y equals c e to the kt, and my initial condition was initially 0, 500,000. So when t equals 0, y equals 500,000. So that's going to give me 500,000 equals c e to the k times 0, which is 1, so c equals 500,000. So I'm going to come back here, actually I'm going to come back here and throw the 500,000 in. So y equals 500,000 e to the kt. So right now I'm looking, it's probably going to be choice A or choice B. So I'm going to solve it for k. Let's see. So when t equals 10, gallons equals 100,000. So that's going to give me 100,000 over here equals 500,000 e to the 10 k. So I bring that over, I'm going to divide both sides by 500,000. That's going to give me 1 over 5 eventually. 1 over 5 is the same as 0.2 equals e to the 10k. I ln both sides. So ln of 0.2 equals 10k. Divide both sides by 10. And that's going to tell me what k equals. K equals negative 0.1609. Negative 0.16094. So that's my k, and I'm going to put that up in here and write this equation. And now I notice that, where is it? Now I notice that it can't be either B or A because that's a positive, and that's a positive. So somehow numerically, e to that is going to wind up equaling one of these. All right? And I'm going to use the graphing utility to test that.
So what I'd like to do is graph all three of these. I'm going to graph the one that I derived, which by the way was negative 0.16094, 500,000. And we noticed that that could not be the ones with E. So we're going to see if it numerically lines up with the 1/5 and the 1/10, t to the t over 10, t over 10. So I had them entered into my calculator. So the first graph is going to be the one that I graphed, and then 0.1 would be the 1/10. All right, so that's going to be my y2, and then this will be my y3 graph, and this is my y1 graph. We're just going to see what happens when I let them fall. And here it comes. This is my y1 graph, the blue graph. My next graph is going to be red, and that's my choice B. Notice choice B does not match up, so it can't be choice B. And then notice it changes color. You see it change color? Let's do that again so you can see it. My y1 graph is the E. And there it is, the blue graph. Then my choice B is the 0.1. And that's going to be a different color. And now, the next one is the 0.2 graph. And watch what happens.
It changes the color of my y1. So choice C is the same graph as my equation, so this has to be choice C.